Salutations. Let's go over the homeworks on the dampened harmonic motion. And I assigned two problems with a forcing function. Then we can do everything. And also in the textbook they ask you only do the steady state, which is the particular solution, but I want you to do the whole thing. There's not really much difference in work. So let's start with number 17. A weight. So let's write down what we read as we read it. A weight, and that the weight is 192 pounds, is suspended from a spring with a constant K is 6 pounds. Okay, so this time they give us the constant. Subjected to an external force of 8 cosine 3t. The medium, it's in the medium that resists the motion with a force equal to 8 times the speed. I hope that the way it was posed is clear what they're talking about. The dampening is just that 8. Oops, what is that? Okay, dampening is just 8. Okay, so we can write down the general formula. Spring equation. And so let's figure everything in. Okay, first of all, we don't have m yet, so we have to calculate m. And m is equal to, we know that weight is equal to mg, so it's equal to 32m, and therefore m is equal to 6. Okay, so we get 6y double prime plus c was 8y prime plus k was 6y equals 8 cosine 3t. Okay, and yeah, it always is simpler if you can divide something out. You can divide everything here by 2, so we get 3y double prime plus 4y prime plus 3y equals 4 cosine 3t. So this is the differential equation that we have to solve, and so from now onwards it's just differential algebra, a differential equation problem. Okay. So step 1, the homogeneous. The complementary homogeneous, that would be 3y double prime plus 4y prime plus 3y equals 0. So we know that we have to look at the characteristic equation. That would be 3t squared plus 4t plus 3 equals 0. Now we can either use the quadratic formula, but we can also think perhaps we can factoring by the ISC method, and the factoring would involve us finding two numbers that multiply to 9 and add up to 4. Right. Well, there are none. Wait, how come? Oh, multiply to 9, add up to 4. Well, there are nothing that does that, right? It's 1, 9 or 3, 3 are the only factorizations. Okay, so then the quadratic formula tells us, okay, what we have to do is then minus b plus minus the square root of b squared, which is 16, minus 4ac. Oh, okay, that is minus 36. Okay, yeah, right, of course. And then divide by 2a, which is 6. Okay, so this is minus 4 plus minus. Now this, sometimes it comes out nice, sometimes it doesn't, minus 20. But it's 4 times 5, so we can divide by 6. So this is minus 4 plus minus, that is an I comes out, a 2 comes out, and then I have radical 5 left. Okay, and that divided by 6, we can simplify by dividing by 2, minus 2 over 3 plus equal to I times 1 radical 5 over 3. We need to split it. This is our lambda, and this is our omega. So we know that our homogeneous solution will be this lambda becomes the power, right? Becomes the coefficient in front of the t in exponential, and then these two guys just give me the cosines, so and the sine. So a times cosine radical 5 over 3t plus b sine radical 5 over 3t. Okay, that is the homogeneous solution. Now, the question is itself asked over the steady state. The one thing one should have, in general, when you do this, you kind of always have to see, is it not by accident that this cosine 3t, that is what we're going to use, right, is a root of the characteristic equation. Sorry, it's not a root, sorry, I say it wrong. What I mean to say is that it is a solution to the homogeneous equation. Of course, because if that would be the case, that would be bad, because if you plug it in, then this thing would just be 0. And that cannot never be, if I plug it in here, it would be 0 and can never be equal to that. Any multiple of cosine 3t, and therefore also any multiple of sine 3t. So if that's not the case, then, and in most cases here with dampening, it will not happen. I don't really know when it could happen, but okay. So here with this, so we know it's no problem. So our particular solution is going to be, well, it's a general linear combination of these cosine and sine 3t. Okay, but as I said, there's no issue here. These are different angles, but also there's also this factor here. That's also something that makes it different. Okay, so we have to take derivatives. Y prime is minus 3a sine 3t plus 3b cosine 3t, and y double prime is then minus 9a cosine 3t minus 9b sine 3t. And so what is the deal? We have to do, the equation is 3y plus 4y prime plus 3y double prime. So so I'm going to write this all together already. So what is the coefficient of cosine 3t? Well, I have to take 3 times this coefficient, so that is 3a. So let me do it in green, right? So this is the coefficient here. This coefficient, but I have to take it 4 times, so that would be 12b. And then the last one is this one, and I have to take it 3 times, so minus 27a. So that is equal to minus 24a plus 12b. And that is supposed to be equal to, is there a cosine? Yes, there is a cosine. This is equal to 4. So this is equal to 4, and we can actually divide by 4, so we get minus 6a plus 3b is 1. Okay, that's our first equation. And the other one is the sine, was the coefficient of sine 3t. So I'll do it in blue. We have b, but it's taken 3 times, so 3b. And we have to take 4 times minus 3a, so minus 12a. And we have to take 3 times minus 9b, so that is minus 27b. That comes out to be minus 24b minus 12a. And that is to be equal to 0, because there was no sign in the forcing function. Right? Did everything correct? Minus 12. Yeah, so we get, here I can divide everything by minus 12, so I get 2b plus a is equal to 0. Okay, and okay, you can do again the method of elimination, but actually somehow I find it rather quick to just solve for a here, especially because of the 0 here, and then plug it in here. I get minus 12b plus 3b is equal to 1. So I see that minus 9b is 1, so b is minus 1 over 9. Wait, that's a is minus 2. Oh. No, I plug it in wrong. No, yeah, no. Plus, oh, no, minus is plus. Plus 12b, plus 3b, so that is plus 15b. Sorry. 15b is 1, so 1. Sorry, let me not scratch things out. I have an eraser. So, so 15b is 1, so b is 1 over 15, and therefore A is minus 2 over 15. So our particular solution, or the steady state as they call it, would be A, just minus 2 over 15, and that was for the cosine, right? Cosine 3t plus 1 over 15 sine 3t. And so if you want to write down the full solution, that would then we have to combine the homogeneous with the, so the general solution would be the particular plus the homogeneous, okay? And so this would be minus 2 over 15 cosine 3t plus 1 over 15 sine 3t. And then we have this guy here, plus e to the minus 2/3 t, right? Was it 2/3? That was my, yeah. And then a times cosine radical 5 over, what was it, radical 5 over 3? Yeah, radical 5 over 3 t plus b sine radical 5 over 3 t. And then we could do an initial condition problem, but because of the numbers are not very nice, so I would always ask you to do it only with nicer numbers, I guess. Okay, that's number 17, and number 20 is kind of similar. So we have now a mass of 1 kilogram. So now we're in this metric system. Stretches the spring 49 centimeter in equilibrium. Okay, so now they tell us what S is, 49. It's attached to a dashpot that supplies a damping force of 4N. So C is 4. The units here are all correct. But we have to just think about that we're doing centimeter, not meter, okay? 4 meter per second. Should that be 400? No, I think not. No. 4 is, no, okay. Find the steady state component of its displacement if it's subjected to an external force of Ft is 8 sine 2t minus 6 cosine 2t. Now this, you would say, oh, if there are two terms, should I do superposition? No, because they are both the same. They're both the trigonometric with the same frequency. And if the frequencies are the same, we can combine them in one combination. Okay, it will be, so we know what our particular solution will look like. It will look like 8 times cosine 2t plus b sine 2t. Yeah, I will swap them around, but it doesn't matter. Okay, so we know that that's how the solution will look like. But let's solve the whole problem because it's set up now. So m is 1, so we get y double prime plus 4y prime. I'm just a little bit concerned about the fact that this is now in no, I think this is correct. Plus plus what is this constant here? Well, we know that k over m is equal to, this is k, right? So ky equals ft. That's our general solution, but we don't know what k is. So k over m is g over the stretch. That we know. We know that g is 980 because we have to do it in centimeters, and the stretch is 49. Oh, I see. I guess I should actually convert in meters. Yeah, right. So no. It's no. What am I saying? What am I doing? This the stretch was 49, which is 20. Okay, so our equation therefore becomes y double prime plus 4y prime plus 20y equals this forcing function. Let me not write it up again. So step 1 is the homogeneous, complementary homogeneous equation. That would be y double prime plus 4y prime plus 20y equals 0. So the characteristic equation is constant coefficients, that's why we can do that. T squared plus 4t plus 20 equals 0. So we have to factor this as two things that multiply to 20 and add up to... No, that won't work, right? Yeah, no, this will be imaginary numbers. Sorry. You can try, of course, but there is nothing that works, so we go to the quadratic formula. So t is equal to minus 4 plus minus 4 squared, 16. I'm so sorry. Minus 4ac, so minus 80. 1 times 20 times 4, divided by 2. Now, this is minus 64. So this is radical minus 64, which is, of course, 8i. So we have that this is plus, minus 4 plus or minus 8i divided by 2. So t is equal to minus 2 plus or minus 4i. So lambda is negative 2 here, and omega is 4. So we see that our general solution, homogeneous solution, will look like, again, these are complex roots. Remember what this means. There is an exponential that has this minus 2 as a coefficient, and then there is the general, then is the two trigonometrics with frequency 4. Sorry, hey, wait, my thing is acting up again. 4. Okay, so this is, no, there's a coefficient still, right? This is a. What is doing this? A cosine 4t plus b sine 4t. Okay. Step 2. I already said what our particular solution look like, so let's start taking derivatives. Y prime is 2 minus 2 a sine 2t plus 2b cosine 2t, and then y double prime is minus 4a cosine 2t minus 4b sine 2t. Okay, and so what is the thing? We have to do y double prime. Okay, so y. Okay, so we have to take this one. Okay. Okay, let's write it up again. Y double prime 4y prime plus 20y equals, that is minus 2a. Let's group, no, let me nonetheless group it now together with the cosine sine, otherwise it's too much writing. So let's look at what are the terms of sine 2t. Well, there is one coming from each time we have a contribution. From y double prime we have a minus 4b. Okay, that is this one, right? From y prime we have minus 2a, but we have to multiply this with 4. So this is minus 8a. Jesus. Minus 8a. And then from y itself, we have to take that 20 times, so that is 20 times b. Right? Yeah. Yeah, always double check which one you called a and which one you called b, right? Okay. So that's that, plus cosine 2t. What are the coefficients there? So from y double prime, it's a minus 4a. From the sine, it's a 2b, but you have to multiply with 4. So it's 8b. And then we have another plus 20a. Okay? So what does this now mean? We know that this has to be equal to the force. The mass was 1, so right. So the equation, where was the equation, right? Well, the equation was, we didn't divide anything, so we just have to take 8 sine 2t minus 6 cosine 2t. So this is equal to 8 sine 2t minus 6 cosine 2t. 8 and 6, right? Yeah. So this means that this coefficient, which is 16b minus 8a, is equal to 8. And this coefficient, which is 16a plus 8b, is equal to minus 6. Okay, so if I multiply this with 2 and add to the other equation, then we get the b's become 32 plus 8 is 40b, and the a's become minus 16a plus 16a, so they cancel out, and then we get is equal to 16 minus 12, 16 minus 12 minus 6. I don't have to multiply that. That is 10. So I see that b is 10 divided by 40. That is 1/4. And if I plug this in the other guy, let's say in the top guy, then we get 16 times 1/4 minus 8a is 8. So this is 4, right? So we'll bring the, okay, so 4 minus 8 is equal to 8a. Okay, bring that to one side and the other to the other side. These things I go fast, right? You can, if this is too fast for you, just pause the video and work it out on a piece of paper. Okay, and so we get minus, what is this doing? I think my juice is up and then it starts acting up. Minus 4 is equal to 8a, so a is equal to minus a half. Okay, and so we have our particular solution, or the steady state as it's called, is equal to minus a half, that was a was for cosine, minus a half cosine 2t, and the other one was plus 1/4 sine 2t. Just double checking that I get everything right here. Don't want to leave it with this. No, that's correct. And so finally, the full solution. Again, the textbook didn't actually ask for that, but let's write it up. So the general solution would be the particular solution plus the homogeneous solution. Okay, so y is equal to minus a half cosine 2t plus 1/4 sine 2t. It's a little bit of copying, but come on, guys. For a quiz, you have all the time. And homework, okay, there. That's not so important anymore. And then, no, that's this one here. A times, no, that's, no, I'm pointing to the wrong one, right? Yes, here it is. E to the minus 2t times cosine 4t and sine 4t, yeah. This weird cosine, and it gets worse. I think my battery is from my pencil is more. 4t plus b sine 4t. Look at this. Okay. All right, that was the homework.